All right, so I am still on the Jack and Jill scenarios. I'm doing activity 2.3 now, an equation for a line not through the origin. So here we had the line of them going from home, and then it says now that Jack and Jill's Aunt Mary lives 10 yards from their home, closer to the bus stop. After spending Monday night at Aunt Mary's house, they leave for the bus stop from there Tuesday morning. They walk at the same rate. So we've got, here's my graph of the relationship walking from their house. So I'm going to compare these two situations. The slope, so I'm going to graph, they started 10 miles from home, but they're still going at the same rate, so that doesn't change. My lines are parallel. They've got the same slopes. How do the starting points compare? I've got one at the origin, and my other one is at y equals 10, 10 yards from home. The next thing I want to cover here was down here. We have the line I've drawn is non-proportional because it does not cross through the origin. That's how I know it's not proportional, because it doesn't cross through the origin. Next, I finish up the table for that new scenario there, starting from their aunt's house. Filled that in. And then how does this translation affect the unit rate? It didn't affect my unit rate at all. And then my equation is going to be y equals 4/3 x plus 10. That's my y-intercept, or that translated up 10 units. And then my general equation, when I do not have a proportional relationship, is y equals mx plus b. This is not something new for us. We've seen this before. All right, I'm going to go over a couple things on the activity 2.4. We have a negative unit rate. And it says, analyze the graph of Jack and Jill walking home from the bus stop. So here they're walking to the bus stop, and here they're coming home from the bus stop. They're getting closer to home. Distance from home is getting closer. Does this situation represent a proportional or non-proportional relationship? This is non-proportional. We don't go through the origin. Is the slope of the line positive or negative? It is negative because it's going down or decreasing from left to right. And then the next thing I want to cover is on 2.5, describing linear equations. So we've got two different graphs here, and we are no longer talking about Jack and Jill. We've got some fruit delivery and a road trip. So it says, determine whether the graph represents proportional or non-proportional. So our fruit delivery is non-proportional. It does not cross through the origin. Road trip is proportional. All right. Then we're going to write an equation. So you're going to need to find the slope, rise over run. Rows 8 ran 60. 8/60 simplifies to 2/15. So y equals 2/15 x plus 20, where that y-intercept is. The road trip, rise over run. I've got 64, and then we are proportional, so it's y equals 64x. All right, C, we had SUV sales. Same thing I needed to do. It's non-proportional. It doesn't go through the origin. And I need to do rise over run, 9/7. That does not simplify, so we have y equals 9/7x. And then plus 30 is my y-intercept. All right, determine the slope of this graph. So we're not able to rise. There's no rise. So that's 0 over how many ever you want to run. We could go from here to here. We're running 2, up 0 over 2. 0 divided by 2 is 0. So our slope is 0. Our equation, y equals 0x plus 5. 0 times anything is 0. We don't write that. So when I have a horizontal line like this, it's going to be in the form of y equals and then whatever that constant is. And so for this case, it's 5. Here, I've completed this table, and this is a proportional relationship. Y equals 6x. And then your numbers probably could vary. You could vary on this one here. The biggest thing you can't have is you couldn't have a 0 here. And then it has to go up by the same every time. So I'm going up 5 every time now. So y equals 5x plus 2, my y-intercept. And then here, I've got my points, and I just need to do a proportional relationship. So your line should look exactly like mine here. And my equation is y equals 5/3 x.
This is an all call for Alex Watson.
All right. This one here was non-proportional, so you could have had it go any which way along the y-axis as long as you did not have it go through the origin. So your line could look a lot different than mine here as long as it crosses through that point. My line is non-proportional, negative slope. Y equals 1/2 x plus 13. And then I've got a graphic organizer to show you here. Slope, here's a different ways to represent slope. Rate of change, talks about rate of change. You can pause this if you need to. All right. And then unit rate is a rate with a denominator of 1. And then we have constant proportionality. And again, this is only used in proportional relationships. So these are all talking about steepness of a line, different ways to represent that. All right, now I'm going to look at the assignment real quick. And then again, I'm only going to start with the practice here. We've got Maximilian is cleaning shrimp. He cleans 4 shrimp every minute. Use the time in minutes as the independent quantity and the number of shrimp as the dependent quantity. So that's y over x there. Is the relationship proportional or non-proportional? I said yes. It's proportional. And it's proportional because if it was 0 minutes, he would clean 0 shrimp. But it's a constant rate of change at 4 shrimp every minute. So the unit rate is 4, and that means he's cleaning 4 shrimp every minute. The equation is y equals 4x. And then I just created a quick graph right here. And I think it wants you to upload those, so make sure you're uploading them when it asks you to. Just take a picture. Consider each graph shown. Determine whether it represents a proportional relationship. So this one is proportional and this one's proportional. Write an equation in the form of y equals mx or y equals mx plus b. So for your proportional, these should be proportional here. That's proportional. And then this plus b is non-proportional. All right, so I have 50 over 5, which is 10. Y equals 10x. On this one, again, it's proportional as well, going through the origin. I have up 90 over 6. 90 divided by 6 is 15, so y equals 15x. C and D now. Okay, both of these are not going through the origin, so both of these are non-proportional. So I need to find my slope, up 4 over 1. Be careful with these units here. Make sure you're following the units. And so that's y equals 4x. And then the y-intercept is 5, so y equals 4x plus 5. The next one here is a negative slope. So we're going down 6 over 8, simplifies to 3/4. Y equals negative 3/4 x. And then the y-intercept is 12, plus 12. All right, and then right here, I've got some more for you. This is just review stuff. We've got a proportional relationship here and a non-proportional relationship here on these two rules here or equations. This stuff here we haven't gone over with Carnegie, so I will let you pause and look over what I did here. But because it's been a little while since we've seen this, but if you have any questions on it, you can definitely ask me. This will not be on the test that you're taking tomorrow. So please come to me if you have any questions. I do not plan on making videos like this every time. If I see some similar errors, I'm probably going to just go over that. But I know we're just starting this, and I want to make sure everybody gets out on the good footing and that we get any questions answered. Please ask them if you have them before we get going too far. Have a great day and do your very best on your test.